About functions, domain, range, what that means, what function notation is, how to tell if it's a function. So we are covering a lot of different topics, thus our nice foldable to keep it all organized for us. Have we learned about functions before? Heard the word function before? Has anybody heard of domain and range before? Good. All right, so we are going to be learning more about that today and then doing some practice with it. So first we have flap. The very first one is flap number 5 that just says functions, domain, and range. Okay, so now open that up so you see your vocabulary flap with the words domain, range, function, relation. Okay, so let's go ahead and fill in what our domain is. Our domain are all of the x values on your graph or all of the input values. So domain are the x values, also known as the input. So the x values of your input. Those are the values you put into your function. You guys might have done back in middle school or elementary school. You had something like this. What was it called? Like a function box or something like that. Remember that? Like, oh. So many grunts and grunts against it. If you put 5 in, then 5 goes in here. 2 times 5 is 10 plus 3, you get 13 comes out. Remember that?
And then when you're a kid, you're like,
Yes.
oh my God,
What's happening in that box? So this is just a function, right? So my input were the numbers that you put into your function. They went in for your x values. So your domain are all of your x values you put in. Okay. My range, does anybody know what the range is? Yeah, it's what comes out. It's your output, which are your y values. So the y values of the output. Y values of your output. So whatever comes out, these are your y values. All of your y values are your range. So domain is what you put in, range is what you get out. Okay? So a function and a relation are two different things. Let's start off by talking about a relation. A relation is just a set of ordered pairs. So a relation is a set of ordered pairs. Remember, ordered pairs are your x, y, written like that. So a relation is basically just a bunch of ordered pairs, a bunch of dots on your graph. When it meets a certain requirement, then we can call a relation a function, only when it meets a certain requirement. So a function is for every x, there is one and only one y. For every x, there is one and only one y. That looks like a nice. Let me get my function box out of the way here. Function machine. What do they call those things?
Yeah.
Oh, I'm gonna have some fancy things. One and only one y. So, for example, if I had the following table of values, let's say I have 1, 2, 3, and let's say it's, I don't know, 10, 28, 6. For each x, is there only one y value? Yeah. So this would be a function. What if I changed it to this, though? For each x, is there only one y value? Now be careful. For each x, there's only one y, right? But what if I had this? For each x, is there only one y? No. My x value of 1 goes to two different y values. So this here would be not a function. So when I have the same x value going to two different y values, then it's not a function because it has to be one and only one y. So if any particular x has more than one y for it, it's not a function. And we'll talk about that more here. So domain, your x values, range, your y values. All of our ordered pairs together gives us a relation. If that relation meets the specific requirement that each x has one and only one y, then we can call it a function. It might help you out to remember domain, range, which one's which. If you think of it alphabetically, x comes before y, domain D comes before R, range. So D goes with your x, R goes with your y. All right, any questions so far? Okay, go and flip up your next flap to is it a function from ordered pairs? You should see something like this. So now we're going to talk about how we can tell if it is a function or not. Remember, each x has to have one and only one y. Okay. So basically, you don't want your x values to repeat. If they do, they need to have the same y. If they have different y's, not a function. All right, so look at your x values. Do they repeat? If they don't repeat, it's a function, because you just have one x of each kind, right? But if they do repeat, look at your y values. If they have different if they have different y values, not a function, because that means it's the same x going to two different y's, just like we saw up in our chart here. So if they repeat like we have here, look at the y values. If they are different y values, then it is not a function. Circle that word not so you recognize it is not. Yeah, so if this was instead of 5, you're good to go. It's a function. That's just the same point listed twice. Yeah, good question. So if they are the same, it is a function. So if this were a 5, it would indeed be a function. Good. Okay, so something we'll be doing is identifying whether or not it is a function, as well as listing our domain and our range. In Algebra 1, we mainly use set builder notation still for domain and range. When you get to Algebra 2, you'll use interval notation. All right, so first let's decide, is this a function? So first look at your x values. Do any of them repeat? No, so is it a function? Yeah. Yes, a function. You only have to be worried if your x values repeat. Alright, so my domain, because I'm listing individual points, I list the individual x's. Alright, so my domain, what are my x values for my domain of this?
0, 3.
Good. So we list them 0, 3, -5. Now, we really should list these in numerical order from least to greatest. So we really should list this as -5 comes first. I know, I made you write it, erase it, and rewrite it. -5, 0, 3. We want to go from least to greatest. I'm going to write that note down here for yourself. Right from least to greatest. Yeah, go ahead and write that in there so you remember to write it from least to greatest. Do you remember? Okay, so similarly with my range. My range are my y values. So 5, 0, 0. If it's repeated, you don't need to write it twice. So I have 0 comes first. You don't have to write the repeat. And 5. 0, 5. Any questions on that? All right. Number 2. Look at my x values. Is this a function? Yeah. My x values don't repeat. No worries. Yes, it is a function. Okay. Then let's go ahead and list out our domain and our range. What is my domain going to be? 1, 2, 3, and 5. Is that you just now? 1, 2, 3, and 5. What is our range then going to be? What's the first number of my range? 4, 5, 6. And again, we don't have to write the repeat of 6. Good. Questions so far? All right, number 3. Is this a function? I heard yes and I heard no. No, why not? Good, so my y values repeat, but not only that they repeat, but what else is true? Right, they have 2 different y values. So x repeated and it went to 2 different y values. Basically, if I were to graph this, it would look something like this, right? For a function, it is not possible for 5 to, when I put it into my function, to get back 12 and 4 at the same time. So for it to be a function, you can't get 2 different outputs at the same time. So that's what's happening there. We'll talk about it with a graph here soon. Okay, so this is not a function. Not a function. We still write our domain and range though. So my domain would be 0, 5, 10. And my range? Good. So we've got negative 1's good. 4 comes next. And 12. Very good. So when we look at ordered pairs, we want to look to see, does x repeat? And if it does it have 2 different y values? 2 different y values for the same x? Not a function. All right, let's go ahead and turn to our next flap. Is it a function from a table? So we've looked at ordered pairs. Those are these coordinate points. Now let's take a look at it from a table. All right, so the rules for a table are the same as ordered pairs. Because all that the table does is list your ordered pairs in a table, right? It's the same thing, it's just listed in the table. So again, look at your x values. Do they repeat? If they do not repeat, then it is a function. If they repeat, look at your y values. If they are different, it is not a function. If they are the same, it is a function. So exact same rules as before. Because it's listing the same information, it's just listing it in a different format. Alright, so I want you to go ahead and try 1, 2, and 3. Decide, is it a function? And also list your domain and range. And remember, input are your x values, output are your y values. Alright, so go ahead and do this on your own right now. Decide if it is a function, and list your domain and your range for each. Give you a couple minutes for that. Did you get the following? Yes, a function. Not a function. Did you catch that 3 is indeed a function? Good. Our x values repeated, but they're the exact same y value. Ah, the tricky one. All right, any questions on that? Go ahead and fix your answers if you need to. So we've looked at ordered pairs. We've looked at a table. They just list the same information in two different ways. Next up is from a mapping diagram. Did you have to deal with these before?
Yeah.
Oh yeah, mapping diagrams. You hate these? I love these. I think they're a clever way of portraying the information. All right. So we now have from a mapping diagram. Oh, I lost the words, didn't I? Hold on a second. Nope, I just plain plumb lost the words. Alright, let me, Alright, give me 30 seconds. Okay, maybe a minute. Don't count! That makes me nervous. Alright. We are back. Okay. When looking at our mapping diagram, the first bubble represents which ones? The X or the Y? Your first bubble represents what? Good. So the first bubble is our X values, or the input. X values, which is your input. The second represents what?
Y value.
Good. And what are your Y values called?
Yeah.
Output. The arrows show us which X and Y go together. Remember, we can have only one Y for every X. There must be one and only one Y. Alright, so I look at my X values. Does each one go to just one single Y? Yeah, so yes, it is a function. Alright, my domain, 2, 4, and 6. My range, 1, 3, 5. Okay, so again, each X can go to one and only one Y. Look at my X's. Does each one go to just one Y?
Yeah.
Yeah, it does. 1 goes to only 8, -3 goes only to 0, and 2 goes only to 0. So again, I basically only have one arrow coming from each of my X's. Okay, so yes, it is a function. My domain, -3, good. 1, 2. How about my range? 0, then 8. Let's go with 0 first, then 8. Good. Okay. How about my last one?
No.
I didn't even get to ask my question. Do my X's go to only one Y?
No.
No. What's the problem?
7.
7. He's our problem child. He's the issue. He tried going to 2 different Y's. That is not allowed. So not a function. How can I change this so that it is a function? Yeah, take away one of them. So take away my arrow from 4, so that 7 just goes to 1, 3 to 2, and 5 to 6. Then we would have, that would change it so it is a function. But as it stands, it's not a function. What's my domain? 3, 5, 7, wonderful. And my range? Thank you, Giselle. I'm glad Giselle knows what's going on over here. All right, any questions on this? Fantastic. Next up, scatter plot. So remember, a scatter plot is just a bunch of dots on our graph. So how in the world do we know if it's a function when we're dealing with a scatter plot? So we should be on, is it a function from a scatter plot? All right. So on a scatter plot, we must find the ordered pairs for each point. Once we have the ordered pairs, we can use the same rules to decide if it is a function. So same thing, your x value can only go to one y value. So we need to look at our ordered pairs, but there's, I think an easier way. Let's just take a look as we go across. Here's my first point. That x value goes to only one y value, right? Go to my next one. This x value goes to only this y value. Keep moving along. This has only one y value. Moving along. Uh-oh. This x value, what's my x value here? 5, right? 1, 2, 3, 4. X is 4. What are my y values for this? Negative 2 and 1, 2, 3, 4, 5. Negative 5. So what we have here is the point for negative 2, and we also have the point for negative 5. I cannot have the same x value going to two different y values. So this is not a function. So if I were to list out all of my points here, negative 2, 1, negative 1, 0, 2, 3, 4, negative 2, 4, negative 5, I see that my issue is here. 4 goes to two different y values, thus we have it as not a function. So it's not a function. This also, writing out the pairs, makes it a little bit easier for writing out your domain and range. Alright, so my domain then would be negative 2, negative 1, 2, and 4. And my range, good, negative 2. Oh, we lost our negative 5, didn't we? I'm sorry. Let's stick our negative 5 in there first, since that is a smaller value. Negative 5, negative 2. Good, 0. Good, 1. And 2. Did I label that wrong? 3.
No.
Sorry. Good. Okay, so let's take a look at number 2. Instead of listing as ordered pairs, I could list it as a table, right? I personally like tables better. What is this ordered pair? Oh, negative 5, 1. Good, negative 5, 1. What's this guy? Good, negative 3, negative 4. This one? 0, 3. This guy? 2, negative 2. And this one? 4, 2. Alright, is this a function? Yeah, none of my x values repeat. So yes, a function. My domain. Oh, look at that. They already have it listed out nicely. Negative 3, or sorry, negative 5, negative 3, 0, 2, and 4. And my range? Negative 4, good. Negative 2.
1,
1, 2, 3. Any questions on that? Okay, so again, it's still just a list of ordered pairs. So next up we have from a graph. I love these ones. How many of you this is familiar to you? You've done this in years past. Good. Good. Should be a refresher. All right. When we have a graph and we're trying to decide if it's a function, who remembers what we use? What do we do? It's 3 words long. Starts with a V, then an L, then a T. Anybody remember? No. What was it? Vertical line test. We use the vertical line test. Who remembers those words? Yes, vertical line test. If you haven't heard it before, welcome to the world of the vertical line test. The vertical line test. The vertical line test is a vertical line. I usually just use the pencil I'm writing with to use it as a vertical line. We use the vertical line test to decide if a graph is a function. If we move our pencil, the vertical line, left to right, our pencil should only touch our graph at one place at a time. If it touches more than once, it is not a function. Alright, so you're going to use your pencil. I'm going to go ahead and try to draw the vertical line here. Let's go with orange. Okay. So use your pencil. Here we go. So you use your pencil. I'm going to use my vertical line here. As I go from left to right, it almost immediately fails, right? It's hitting in two different points. This means that my x value, what's my x value right here? 0. Yeah, my x value right here, let me zoom in a little bit. My x value, let's see if this works. Okay, my x value here is 0, and if I look, when x is 0, how many different y's does it have? It has 2 of them. Remember, it has to have one and only one y. So my vertical line test, if I'm hitting it in 2 places, that means there are 2 y's for that one particular x. So that's what the vertical line test is doing there. We're checking to see if it has just one y. So as soon as it fails, not a function. All right, so let's go ahead and declare this as not a function. Not a function. Let's go ahead and first decide if these are functions, and then we'll go back and do domain and range, because we have to write it a little bit different because we have graphs here. Okay, so let's decide our next one here. Is number 2 a function? Yeah, even though it's curvy and wavy and kind of crazy, all along it's only hitting in one point. So this is a function. Yes. A function. All right, how about number 3? Number 3 a function? Yeah, that's a function. Yes, function. I feel like number 4 is kind of tricky looking. When we do number 4 and we bring it along, just 1 point, 1 point, 1 point, right here, it's only hitting that one particular point. It gets really, really, really close, but it's only hitting that one dot that you see on your graph. So this is a function. Yeah, this is a function. So 4 is yes. A function. So then, how can I change my graph of 4 so it's not a function? What could I do? Yeah, make it, instead of this going over there, make it like that. It fails the vertical line test. So this, if I were to do this, it would not be a function. Good. Okay, so let's take a look at our domain and our range. So our domain and range, here we have what are called continuous graphs. So I want you to, just off to the side here, write, where should we write it? Let's write continuous graphs down here. Continuous graphs. continuous graphs is where you have a line, like this, a line or curve of some sort. Line or curve. These are called continuous graphs. You can move along it. You can trace with your pencil and never pick up your pencil. Now flip back one to your scatter plot. Our scatter plots are what we call discrete graphs. So just write down here. I think it's spelled like this. It might not be. I'll check and see. So discrete graphs, which is a bunch of points. Okay. So when you have to pick up your pencil to move from one to the next, it's called a discrete graph. And I do want you to know that vocabulary there. So a bunch of points, discrete graph, you have to pick up your pencil to move it along. But if you can trace it a nice, smooth curve, that's called continuous. You don't have to pick up your pencil. Okay. So for discrete graphs, we had to list each individual point. But for continuous graphs, notice we have all of these values. So if I look at my first function here, let me zoom in on just this first function. If I look at this first function here, would you agree with me that we do have an x value of -1? And would you agree that we have an x value of 0? And also 1, and 2, and so on and so forth? Don't we also have 1.5? Don't I also have 0.9? Don't I also have 0.9999999? Yeah, I have all of these x values, all of them. So it's not just individual points, but every single x value over here. If I were to take my x, if I were to trace my graph here and bring down all of my x values, it's all along here, right? It's everything starting from here over. All of my x values, as I move from left to right, I start right here at -1, and I have a graph for the rest of my numbers, all the way out to infinity. So that is kind of how we write out our domain here. When I move from left to right, because we always go from least to greatest, so left to right. So my domain, I'm talking about my x values, so we have to write this in set builder notation. Talking about your x values. So x such that. Now we want to write an inequality. My x doesn't start until -1. And x is everything bigger than -1, right? So x is everything bigger than or equal to -1. You could have also written it like this. X is everything bigger than or equal to -1. Same thing either way. So we start at -1 and it's everything bigger than that. So we use our open mouth towards the ends. Now my range, I want to start from the bottom. See how this is an arrow? That means it's slowly going to the right forever and down forever. So it's forever going down, 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 down. What do you think is your smallest y value? Yeah, -infinity. Very good, Zayad. It goes forever down, so that's forever -infinity. Okay, so we know it starts at -infinity. As I move up, it's climbing, climbing, climbing. When does it stop? Never. It goes up forever and to the right forever. So that means it's going to positive infinity. So that is all of my real numbers, right? Everything from -infinity up to positive infinity, all of my real numbers. So whenever I have all of my real numbers, so range, I'm talking about y, such that, when it's all real numbers, does anybody remember that notation for it? It's a weird looking R. Y, okay, so bear with me with this notation. Y, it's a weird looking E. That means Y belongs to The real number system is an R with 2 bars here. Okay, so practice writing that out.
Right.
Y, weird looking E, double bar R. Sounds like a candy bar, double bar R. This means Y belongs to the real numbers. It's all of your real numbers, everything from negative infinity to positive infinity. Okay. Any questions on that? Okay, let's go ahead and do our other ones, give us a little bit more practice with it. Okay, so these arrows, again, it's continuing in this pattern, forever going like this. Forever and ever going like this. So if I start from the left, where does it start? Forever that way, right? What is that again? Negative infinity. And it continues, 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 continues all the way to positive infinity. So my domain this time, x, such that, well, your domain this time is all real numbers. So x belonging to all real numbers. Looks like that. X belongs to all real numbers. Now your range is a little different here. When I go from bottom to top, least to greatest, when does my graph start? Right here. What is your y value there? Yeah, -3. Okay? And then as I move up, I still have graph, I still have my graph, I still have my graph, and what's the highest point? Yeah, positive. So my y values, my range, is y such that y is between -3 and +3. So we just write this as an inequality. It's between -3 and +3. I actually have that value, that point, so I actually have the line underneath it, or equal to. So it's everything in between -3 and 3, everything in between -3 and 3. Alright, so let's try 3 and 4 now. You're going to like 3 and 4. Okay. This continues forever down and to the left. This continues forever up and to the right. Alright, if I'm starting all the way down here, and then I'm going all the way up, what are we going to have for that? Yeah, all real numbers. Good. All real numbers. So go ahead and write that notation out for that. Okay, so our notation for our domain, we should have had x such that x belongs to the real number system, all real numbers. And for our y, so we did our y's, our x's, they're also, remember, from the bottom to the top, all real numbers as well for my range. So my y's is the same thing. It continues forever to the left, continues forever to the right, continues forever down, continues forever up. All real numbers for both. Alright, number 4. So this is continuing also forever to the right, or sorry, that would be your left, wouldn't it? Forever to the left, forever down. This is continuing forever up and forever to the right. It's slowly going down, but it is forever going down. So if it's forever to the left, forever to the right, what's my domain? Good. X such that x belongs to the real number system. And if it's forever down, forever up, what's my range? Yeah. Y such that y belongs to all real numbers. That's it there. When do you put numbers instead of all real numbers? Let's take a look at, so up here for number 2, notice that your y values didn't forever go in either direction. So your lowest point on your graph was -3. Your highest point on your graph was +3. So that's going to be in between there. Similarly with number 1, for your domain, as I go from left to right, my graph didn't start until here. So my smallest x value, smallest value to the left, was -1. But then it continued forever to the right. So when you have a max and min, basically a starting and a stopping point, that's when you're going to use your inequalities. But when it forever goes on, forever and ever and ever, in all directions, that's when it's all real numbers. Good question. Any other questions on this? I know it's a lot of weird stuff. Did you have to do this before when you did your functions? Probably not. I didn't think so. So that would be your first new thing for today. Okay. And last, but certainly not least, function notation, your last one. Purple, right? Alright, so function notation. Has anybody dealt with, let me turn it to the page. See this new notation here? F of x, g of x? Did you guys deal with that at all last year? Oh, really? A little bit? Some, yes? My goodness. Okay, so for those of us that haven't seen it before, this is what's called function notation. So all along you've just been doing y equals, or h equals, or z equals, or some letter equals. But now we have what's called function notation. So that once we know a relation is a function, remember relation is just a bunch of points. If it meets that requirement that each x has one and only one y, we call it a function. So using this notation allows us to communicate, hey guys, this is a function. So we use function notation to do that. So before, your old ways, you might have an equation such as y equals 2x plus 1. Well, now with function notation, instead of y, we write f parentheses x parentheses equals 2x plus 1. This does not mean f times x. What this is called f of x. So the function of x. X is my variable, my input, and this is a function of my input x. So it really just means y, your output values. So before, we would write an ordered pair. I don't know, give me an ordered pair. What do you guys want?
2, 1.
2, 1, all right. So before you would have had the ordered pair 2, 1. Well, our function notation, this is my input, right? 2 is my input. So f of x represents your input. So I would have f of 2 is my input equals my output, which is 1. So 2 is my input, my x value. What it equals is 1, your y value, because f of x just means y value. So f of 2 is the y value at 2. I like function notation because it tells us more information. If I just said y equals 1, then I wouldn't know what was my x value for that. All I know is y was 1, but I don't know what my input was. Function notation lets us know what my input was. When x is 2 in my function, y is 1. Right? So then the old look for evaluate is it would have said something like this, and you're going to want to write small. Evaluate y equals, I don't know, 3x minus 5 when x equals 4, right? So this would have been your instructions before. Evaluate when x equals 4. Evaluate my function when x equals 4. Well, now I can communicate that through function notation. Instead, you're going to see find f of, I want to find it when x is 4, so f of 4, when f of x equals 3x minus 5. So instead of saying evaluate my equation when x is 4, find f of 4 when my function is this. Meaning, again, 4 is my x value. Instead of x, I have 4. So instead of x, I put in 4. So if we have more than one function, we give them different names so we know which one we're talking about. Instead of having y equals y equals y equals, if I tell you, all right, find y equals, you don't know which function to use. So we use different names. So we might call it f of x. That's the most common one. Sometimes you might see g of x. You might see h of x. You could honestly see any letter. It could be z of x, d of x, but those are the most common ones. Okay. So we're going to be using this function notation is actually what you'll use this year as well as big time in Algebra 2. And if you choose to take math classes after that, function notation is the main thing. It's like you've grown up and matured, you can handle function notation now. It's no longer this baby math. All right. So given the domain of 0, 1, 2, 3, make a table for the function. Right. Let's just do number 1 here. So they gave me my domain. Domain is which ones, x or y? Good. Domain are your x values. So they told me my domain is 0, 1, 2, 3. So now I need to find my y values, or what is called your range. So all we do is find each of my y values. Just like before, I'm going to take 0 and put it in for x. Same thing now. So remember, y is just the same thing as f of x. So when x is 0, y is, so we take 0, put it in. What's 2 times 0? And what's 0 plus 4? Good. So 4 is my value there. All right. So now let's put in 1. 2 times 1 plus 4. What's 2 times 1? And plus 4? Good. All right, next up, 2. 2 times 2 plus 4. 2 times 2 plus 4. Good. And last, 2 times 3 plus 4. 2 times 3 plus 4. Good. Does that make sense there? Nothing's really changed, just different notation. All right, so now let's take a look at let's do number 4 here. Given the range, find the domain. So here they went backwards, right? They gave us the range. Range is which one? Good, your range are your y values. So my y values are 0, 5, and 10. Then they want us to find the domain. A little bit trickier, right? They've given us this, now we have to solve for x. So domain are my x values. So let's maybe rewrite the equation and solve for x. It'll be a little bit easier to solve that way. So let's rewrite this here. H of x is the same thing as y. So y equals 5x. Right? Now I could, for each individual problem, put in 0 and then divide by 5. Put in 5, divide by 5. Put in 10, divide by 5. But it's going to be easier if we just start off by solving for x. I need x, so let's solve for x. So how would I get x by itself? Yeah, divide by 5. So then I have x equals y over 5. I need x, so I solve for x. Okay, so now it's going to be a lot easier. Take y, put it into your equation. What's 0 over 5? Yeah, if I have 0 cookies to share with 5 people, each person gets 0 cookies. Now put 5 in for y. 5 divided by 5? 1. Okay. Now put 10 in for y. 10 divided by 5? 2. Up here, it was already in the form y equals. We wanted y. It was already solved for y. Down here, we needed x, so we had to first solve for x before we put it. All right, let's go and do number 6 next. Find f of 3 when f of x equals 9x plus 2. So this is evaluating. I'm taking 3, and normally it's f of x. Well, they want f of 3. So I'm simply, this means that x equals 3. So all I'm doing is taking 3 and putting it into my equation. So f of 3 equals 9 times 3 plus 2. F of x, here's x. F of 3, here's 3. I'm just replacing x with 3. So f of 3, my y value when x is 3, equals this. Well, we know what that actually is. What's 9 times 3? Good, 27. What's 27 plus 2? 29. So f of 3 equals 29. Let's read today. Okay. Let's go and do number 7 so you can get a little bit more practice with it. Find f of negative 2 when f of x equals negative 7x plus 3. So f of negative 2, I take negative 2 and put it in for my equation. So negative 7 times negative 2 plus 3. Again, f of x, negative 2. Alright, what's negative 7 times negative 2? Good. Positive 14. Very good. And 14 plus 3? Good. So f of negative 2, my y value when x is negative 2 is 17. If I were to graph this, negative 2, and then up to 17, however high that is. This is your x value, this is your y value. F of x gives you your y. Alright, so let's finish up with number 8 here. Find f of negative 1. Negative 1 is my x value. So look at your graph. Go to x is negative 1. What is your y value here? 0. So just equals 0. Letter B. Find f of 2. And x is your 2. So go to x equal to 2. What is your y value? 3. Now here's a trickier one. Write this in. Let's see. When f of x equals 1, x equals what? This is a trickier one. When f of x equals 1. What does f of x represent? Your y value. F of x as a whole is your y value. So this is saying when y equals 1. Okay, so let's go to where y is 1. Right here. What is your x value? Here's my point. What's my x value? Yeah, negative 2. So when f of x equals 1, it's saying when y equals 1, what does x equal? Negative 2. This guy right here. Alright, I know that was a lot today. You guys did really well with it. Hopefully there were only a couple of new things. Most of it was review. Your homework, I will be passing out to you. It is a longer homework, but notice that there's some multiple choice, okay? So your homework is going to be this day 2 homework. It's 2 pages. I'll pass around staplers for you. And the next class we'll be reviewing all of this as well.